Okay, so last time we did 10.1, which was just a lot of square roots and using your calculators and going through everything. This 10.2 and 10.3 is going to kind of expand on that just a little bit. 10.2 only has 2 objectives in it. And this is going basically, when you see this, it's going to talk about going from radical to exponent form. And this part, there's no math in this part. Now, the first objective, there is no math in this one. It's basically just rewriting it from one form to the other. And the questions that they do for this one, they either give you something in radical form and tell you to rewrite in exponent form, or give you something in exponent form and have you rewrite it in radical form. And basically is this. We'll just go through some examples and show you some of this part. That if you have something here that's in exponent form or exponential form, if you have to change it to radical form, it's only really one simple, I guess 2 things that you have to do with this one. Radical, so you're going to have the radical sign in there. And basically this, the bottom number in the fraction goes on the outside. The top number basically goes to a power that's going to be on the inside. So if you have x to an exponent on this one where you've got the numerator and denominator that's in exponent form, your denominator is going to be the index that's here, and this x to the n becomes the power that's here. And that's all that they're going to have you do when they go back and forth on these. So top number is your power, and your bottom number becomes your index. And all they're going to have to do is just give you, 3 or 4 different questions, and just have you go back and rewrite it from one to the other. There's no simplifying in this part. It's just simply going to ask you to rewrite these. So if you have, 7 to the 1/6 power, and they ask you to rewrite this one in radical form. Your base here will stay the same, so the 7 is here. That 6 becomes the index. And if it's 7 to the first power, you don't really need the 1 on that case. So that's one of those, if it's 7 to the first power, you can just leave that 1 off and just make it so it's the 6 root of 7. Okay. The only other thing that they'll do then is just have you go in reverse order. They'll give you something in radical form, and then they'll ask you to rewrite it in, or put it in, exponent form. Sometimes I say exponent, sometimes it's exponential, but basically the same thing. And on that one, you're just going to do everything in reverse. You're going to have your t that's here, and you're just going to make it a fraction. This is to the 4th power, so that your numerator, that 5, becomes the denominator. And again, nothing more than just rewriting these. There's no math involved on this one, just rewriting the different parts of what you have here. And then one more here, basically on the same lines. Doing the 6th root of b. Okay, so if you've got the radical here, you're going to go back and rewrite it in exponent form. Technically, that's b to the 1st power, and 6 is the index, so it's just b to the 1/6. Okay, and objective 1 is that simple. There's no math involved on that one. There's nothing else that you have to do when you go through these. It's just getting you to rewrite this one and just figure out the different forms of what you get for this one. Objective 2, though, this is where you actually get to do some math. And for one like this, they're going to ask you to rewrite it in radical form and then simplify. All right, and this one, two things that you have to do. Obviously, you're going to rewrite it. I think they call this rational exponents when I talk about this part. Okay, and really, when I talk about the rational exponents, you're just going to do those two things. You're going to rewrite it in radical form, and then once you do that, then it should ask you to go back and simplify that one just a little bit. So you're going to start with a problem something like this, which 27 to the 4/3 power. Okay, so go ahead and rewrite it, make it 27. And again, that'll make that the 3rd root to the 4th power. And for one like this, they kind of give you the option saying, all right, here's where your two options kind of kicks in. And depending on the problems and how you go through these, you can do them 2 different ways. But because you've got this number to a power and you've got the root on it, you can either do this part first and then take the number to the 4th power, or you can do the number to the 4th power and then take the 3rd root of it. So you can kind of go either way on this one when you go through the parts on this one. The way they set these up, it's probably going to be easier to do this part first. Because that part, when they give you these for this way this sets up, that should be a number that you could just, if you've got a good calculator, you can punch in the 3rd root of 27. But again, if you were taking that and breaking it down, the 27 would be 3 times 3 times 3. Which, if you do that, that's the 3rd root of 3 to the 3rd power. And as long as these two powers and index match up, remember, those two things will cancel each other out. So this would be 3. And then we would take that to the 4th power. Do that. There you go. Oh, it matches up a little better. So taking the 3rd root of 27 and just breaking it down until we get to this point, you get 3. Now you can do 3 to the 4th power, which is just 3 times 3 times 3 times 3. Multiply all that together, and that would then be 81. All right, let's give you a few more of those. Make sure we got it here. So for this one, we'll do 81 to the 3/4 power. So if you rewrite it, that's the 4th root of 81 to the 3rd power. And again, you can either do 81 cubed, which is a really big number, but again, they're trying to get you to think about that, okay, let's do the 4th root of 81 first, because that should be just a number that we can do. And if you go back and check the 4th root of 81, 81 is 3 times 3 times 3 times 3. So this would be the 4th root of 3 to the 4th power, if you want to look at it that way. Then we're cubing that. And again, if the index and the power are the same, they cancel each other out. That's just going to leave you with 3 on the inside, and then it's 3 to the 3rd power. So 3 times 3 is 9. 9 times 3 would make that out to be 27. So, and every one of these in 10.2 is going to work out that same way. It's always going to work out nice and perfect, that whatever number that you do, it's going to be a perfect number when you pair this thing off, and we'll do one more here. So let's do 125 to the 2/3 power. Okay, again, first thing is we'll rewrite it. So it's 3rd root of 125 squared. And then same thing, we're going to go ahead and do the 3rd root of 125. And if you break that part down, that's the 3rd root of 5 to the 3rd power. Then we're going to square that. But again, the third power and third index cancel each other out and just makes that 5. So that becomes 5 squared, which will make it out to be 25. Okay. So that's in 10.2. That's the only 2 objectives. The first one, you're just going to rewrite it. The second one, then they use that to have you rewrite it. Then use your calculator or just take the number that you get and break it down. And then just kind of go from there. Okay. And then 10.3. is all just simplifying radicals. And then they start you off with some really easy ones, not as easy as the ones we did in 10.1, because if we go back to 10.1, basically you had something like square root of 25, where you would just take the number and tell me the answer was 5. This one in objective 1 for this part, they're not quite that easy. This is one where they're not going to be perfect square roots, so it's square root of 50. Okay. If you have to simplify the radicals on this one, this is where you're going to break this number down in terms of prime numbers. And this is going way back to when you had to use the old factor tree and take the number and break it up and do all the things. So basically you're going to take 50 and just start breaking this thing up. You can do 5 times 10. 5 is a prime number, so that's as far as that one will go down. 10, you can make that 2 times 5. And both of those are prime numbers. Okay, and if you've forgotten your prime numbers, that's 2, 3, 5. That's your big 3. I mean, that's really the 3 main ones that you'll use. 7 is kind of the next one that you use. After that it would be 11 and 13 and all those other numbers. But really, 2, 3, and 5, that's your main 3 prime numbers you're going to break everything down. The other numbers kind of pop up as you divide out the 2s and the 3s and the 5s. So if you have square root of 50, then basically here's what you can do. Just go back and rewrite it so you have all these numbers kind of written out, 2 times 5 times 5. And then they're kind of getting you to see this, is that if you have 5 times 5, that's 25. But the square root of 25 would just be 5. So you could take that part out and just make that a 5. And then the 2 doesn't have anything to go with it, so it stays on the inside. When we talk about this, I always talk about being like exit buddies. Just like Finding Nemo. When they're on the back of Crush and they're cruising around the EAC, and you got to find your exit buddy. Same thing on this one. That if this is in the EAC to get out, you got to have 2. They got to have a buddy to get out. They got to be the same thing. So once they can buddy up, you'll take that number out, and then. But again, if you think about it, that 5 times 5 is 25. Square root of 25 is just 5. And it kind of goes from that part. If you tie it back in with the way they were talking about it in the homework in the sections before this, it would have been 2 times 5 squared. So the square root of 2 is okay. When you do the square root of 5 squared, again, technically that's the second root. So those 2 things cancel out, and that 5 goes on the outside. So, that's kind of the way that they get to that number when they go through this thing. Okay, so that's the first, and again, we'll just do a couple of numbers just to make sure that you kind of get the idea of what we're looking at here. For the second one, let's go with square root of 28, maybe. And the only difference in the first 2 objectives, objective 1, all the numbers stay less than 100. Objective 2, they give you numbers bigger than 100. Still the same concept as you go through these. Now, here's one thing you can do. If you start to take this number and break it down, if you took 28 and broke it down and made it 4 times 7, if you run across a number that's a perfect square, square root of 4 is 2, you can go ahead and break that number, and if this number doesn't break down any farther, then that's your answer. Now, and sometimes you'll run across one of those perfect square numbers as you're breaking this thing down, depending on how you break it down. Sometimes you don't. If you don't, let's say if you'd taken 28, and broken it down and made it 2 times 14, and then you had 2 times 7, well, then you would see that you've got 2 times 2 times 7, There's your pair of 2s, so that 2 will go on the outside. The 7 stays on the inside. And sometimes it just, as you break these numbers down, you may run across a perfect square root number. And if you do, you can kind of, make a little bit of a shortcut as you go through that one. If not, you can always just break it down, all the way down to prime numbers till you get 2 times 2 is 4. But if you take the square root of 4, that would make that 2, and then you've got the square root of 7 there. So either way you go, it's really just kind of up to your choice as you go through that one. Okay, objective number 2 just makes the numbers a little bit bigger. Everything in the first objective, it's all numbers less than 100. Objective number 2, it's going to be simplifying radicals where it's bigger than 100. Which just means you got to break it down a little bit more. Okay, now I'm going to show you, other than the factor tree, because I can remember doing the factor tree on big numbers like this where it was like 240 or 500, some number you had to break down. And I can remember breaking it down perfectly, but then I had so many arrows coming off of it where I was breaking it down, I'd miss a number. And just, not because I didn't have it, it was hidden somewhere in this one. Here's another option you can do to do instead of doing the factor trees, this is something that some people call it the ladder method, or the stack method. Depending on which one you want to call it here. Everybody calls it something different. That instead of doing the factor trees where you break everything off and you're circling the prime numbers, the ladder or the stack method says, all right, let's do this. Let's take the number of 175, but do a division problem on it, but we're going to kind of do it upside down. The only catch is if you do this one, you're only going to put a prime number on the outside. So we're going to divide 175, because as the number gets bigger, it's harder to find those perfect square numbers that jump out. So this one, you pretty much have to go back and do the 2s and 3s and 5s and 7s. So this is one where I tell people, all right, just start dividing it by numbers that you know with 2s, 3s, and 5s, because that's really the main ones that you're going to use. And when it comes down to that, the 7s will pop up occasionally. If they do, that's fine. This one, you can divide it by 5. So we'll go back and divide it by 5. So divide 5 into 175, that'll go 35 times. Okay, so it's an upside down division problem. Do the same thing again. What can you divide into 35? Divide by 5, right? Make it 5 times 7. And how you know you're done is when you get to the bottom and this last number's prime, you know that you're done. So now everything's, and they call it stack method because all your numbers are stacked up here. They also call it ladder method because it kind of looks like a ladder that's upside down. So 175, you could rewrite that as 5 times 5 times 7. Well, there's your pair of 5s that get to go out. So that makes that 5 and then square root of 7. Now, if you're good with the factor tree, you can do that. This is one of those that once I saw this option, I liked it a lot better because, again, it stacks everything up, especially if you got some bigger numbers that you're going back and trying to break down here. So if you got something like, 160. That's one, if you start breaking this thing down, you're going to have factor trees going every different direction. So this is one where if you can kind of stack this thing up, it does make it a little bit easier to do this part. So we'll flip this thing upside down and go upside down division problem here. Okay, and if it's a bigger number, I tell people start small. If it's even, go back and divide it by 2 every single time. 2 will go into 160 80 times. 2 will go into 80 40 times. 2 into 40 to get 20. About 2 into 20 to get 10. About 2 into 10 to get 5. Okay. And again, instead of having factor trees going every different direction, it's all lined up. It's 2 times 2 times 2 times 2 times 2 times 5. And you can go ahead and start pairing these things off. There's some 2s. So you can take that 2 out. There's another pair of 2s. You can take that 2 out. That 2 times 5 doesn't have anything, so it'll stay on the inside. So we took this 2 out, we took this 2 out, multiply those two together to make it 4. These two are stuck on the inside, so you multiply them together to get 10. Okay, and now again, one of those, if you were thinking a shortcut on this one, again, sometimes those numbers are jumping at you. If you started breaking this thing down doing the factor tree, maybe you saw that would be 16 times 10. And you go, oh, well, the square root of 16 is 4. The 10, I can't break that down anymore. So now I can make it 4 square root of 10. And again, if you see a number like that jumps at you, you can go ahead and do that. You don't have to go through the whole steps on this one. But if you don't see that number jump out at you, just go back and and to me, this one's a lot neater and a lot cleaner because everything is lined up and it's all, stacked up to get those numbers out of it. Okay, objective 3. Same thing on this one, but now it's, I think they're saying you're simplifying radicals with univariate monomials. Basically means they're throwing letters at you. They're throwing the variables in here. And again, we got the list of the blah, blah, blah definitions that they give to you here. This one's you're simplifying radicals with variables. Okay, did we do this last time in 10.1? Maybe? Did we do, go back and tell me, I can't remember if we did. Did we do like the square root of x to the 40th? Did we do something like that? Do I remember? Maybe, maybe not. I can't. Oh, okay. So we did do a couple of those? Okay. Alright, so if you remember from last time, we'll kind of go back on this one, that if you were doing just the variable, index here was 2. We said the shortcut is that if you took this thing and rewrote it in exponent form, you would just divide these two numbers. So that's x to the 40 divided by 2. Well, 40 divided by 2 is 20. So we kind of talked about rewriting it that way last time. The only thing they're going to do in objective 3 here that's any at least a little bit different is they're still going to do this same thing. They're going to have you work with some variable, and really you're just going to divide these two numbers. You're going to divide the power on the inside by the index on the outside. That again, really, when we're doing that, we're really just rewriting it from a radical form back to an exponential form for the variables. So the variables are just that straightforward. Take the index here, divide it into this number, work it out, you got the answer that you're looking for. Okay, now here's the thing they're going to do different. That again, we talked about it a little bit back in 10.1. The only thing they're going to do different with these today is they're going to give you a number, and it's going to be something like this, where it's the square root of 28. X to the 10th or something like that. And if you have these, basically you're going to do it in two parts. You can do the square root of 28, and then we'll do the square root of x to the 10th. So you can break it up into two parts when you go through this. Okay, if you take the 28, start breaking it down, that's 4 times 7. And hopefully you go, okay, square root of 4 is just 2. So that would be 2 square root of 7. And if I'm taking x to the 10th, again, it's a square root, so that's technically a 2 out here. I'm just doing 10 divided by 2, which makes that x to the 5th. So simplify the number, there's your answer here. Simplify the variable, there's your answer there. And that is the answer that you're looking for. Okay, now, and most of these should be, they might sneak in a perfect square number along the way, but I think most of these should be that when you break the numbers down, you'll have something with a radical and something with the coefficient that you can break off on the outside. Okay, so if we do square root of 54 and the square root of V12, if you take 54 and start breaking it down, you can make it 9 times 6. And hopefully you go, all right, well, square root of 9 is just 3, so that would be 3 square root of 6 on this part. V12, again, that's technically the second root, so it's just 12 divided by 2, which would be V to the 6th. And that would be your answer right there. Now, and depending on the problem, they shouldn't count this wrong, but they may also let you rewrite this as like 2x to the 5th square root of 7. So that may be an option for an answer also. That they may take everything that you would break out of the exponents or out of the radical and put it in front, and then anything that's left over on the inside would then go on the end of it. So like this one, it could be 3v to the 6th square root of 6. So they could have you rewrite it in either one of these two ways. I don't really care. As long as you got the answer, I don't really care. The biggest thing on this one is just make sure that x to the 5th is not on the inside of the square root. If there's any one benefit to that one of putting this number first, it's there so that you know that it's not on the inside of the radical. That's probably the one good benefit of doing one that way. Okay, so that's spinning off what we did in section 1, just bringing those two parts together and kind of putting it all together. And then objective 3, I say, well, okay, let's do this. Still going to simplify variables, still working on this one, but they say, all right, what happens if we're doing this one when, let's say you have the square root of u to the 21. Still going to take this u, take the 21 and divide it by 2, but what happens when it's not a perfect square root? Or it doesn't come out even? Because this one we're going to get some fractions and decimals left over, right? So here's what I kind of like to do on this one, especially if you have more than one variable along the way. Now, they're going to tell you, probably a lot of times they tell you, you're going to rewrite this one so that you have it so that you take the highest multiple of the index that's here, and then you rewrite the part that's left over. Okay, and you can do it that way, but we're going to do it the old-fashioned way. We're just going to take 2 and divide it into 21. Okay, how many times will 2 go into 21? 10 times, right? Leaves you with 1 left over. If you do it this way, the top number that you get on top here, the whole number you take out, that's going to be the number that goes on the outside. Oh, not number, say exponent variable on the outside, sorry. And your remainders, well, that's what's going to remain on the inside. Okay, so and to me that one was always, I understood when they talk about pairing it up and doing things and finding the multiple, you know, so, okay, but it's a lot easier just to say, okay, if we're dividing this number, let's go ahead and divide the number. 2 are going to 21 10 times. We've got 1 left over, which means when we rewrite this problem, we're going to have 1 u left on the inside. We're going to put 10 u's on the outside. Okay, and that's it. That's all you've got to do when it comes down to it. And sometimes when they talk about, you know, rewriting it and finding the pairs, and people get, and sometimes it gets a little lost in it. And it's, let's just keep doing what we're doing. Let's just keep dividing this thing, because that's really all that we're going to do when it comes down to something like this. And if it's the square root of x to the 17th. Same thing, we're just going to divide 2 into 17. Goes 8 times with 1 left over. So we need x to the 8th is going on the outside, and 1 is going to be left on the inside. So we're going to have x to the 8th is going to go on the outside. On the inside, we're going to have 1 left over, so we're going to have the square root of x to the 1st, which again, we can just leave it as just x there. Okay, so if they give you something like the 4th root of, t to the 97th power, let's go 99. Okay, we're just going to divide 4 into 99. 4 going to 9 2 times. 1 left over. 4 going to 19 4 times with 3 left over. So again, that's our outside power. And the remainder is what's on the inside. Because again, it's remaining on the inside, so that's the remainder part of it there. So if we break this thing down, it's the 4th root of, we're going to have 3 x's on the inside, and we're going to have 24 x's on the outside. Okay, so still that same thing, that if you can just think that it's just dividing, and again, really we're rewriting this part, if you want to think about it this way, we're just rewriting this as x to the 17 divided by 2, and then we're just going to go back and divide the 2 and the 17 to figure out what that power is going to be. But they're going to tell you to leave the answer in a radical form, which means if that's the case, we don't have to worry about rewriting it, we just have to think that we're just dividing the 2 into the 17 here. Okay, so that was objective 4. Objective 5, well, they kind of do the same thing, but now they're going to give you some numbers and some variables, and again, they may or may not come out perfectly. So you have the square root of 49 x to the 9th. So we got the square root of 49 times the square root of x to the 9th. The square root of 49 is just a plain old 7, so that one's good there. If you've got x to the 9th, again, we're going to take, for this thing, we're going to take 2, because that's our power that would be here. Divide it into 9. Goes 4 times with 1 left over. So we need 4 x's on the outside. We need 1 x on the inside. And I think most of these in Objective 5, they're always going to, from the ones I saw, they came out to kind of have that same pattern. They're going to give you a perfect number to start with, and then they're going to give you a number that we're going to have it to an odd power so that, you're going to have some leftovers here when you go through something like this. Maybe it's t to the 7th power or something like that. Okay, so we got the square root of 25, which would just be 5. T to the 7th, again, that is a second, our index of 2, so we're dividing 2 into 7, which goes 3 times with 1 left over, so that means we need 3 t's on the outside, and then 1 t on the inside. Okay. Objective 6, they make a really small step. They say, all right, well, if you can do it with 1 variable, can you do it with 2 variables? So now they're going to give you 2 variables when they go into the next part of it here. So we'll go square root of 81 x to the 5th and y to the 7th. Okay. And again, you can take each one, as long as it's all multiplied together, which is what you have here, you can take each little piece and break it up and do it one piece at a time. Square root of 81 is 9. X to the 5th, again, it's second root, so if you divide 2 into 5, that'll go 2 times with 1 left over. And for the y's, again, that's the second root, second index there, we're going to take 2 and divide it into 7, goes 3 times with 1 left over. Okay, so putting all this together, we've got 9 here. We've got 2 x's on the outside. We've got 1 x left over on the inside. So, and if you stack it up this way, where you do each one at a time, everything on top is what goes on the outside. Everything that's in your remainder, that remains on the inside. So for the square root here, we're going to have 1x on the inside and 1y on the inside. But we've got 2 x's and we've got 3 y's that would then go on the outside. Yeah, and one more of those. Let's go with the square root of 27. So y to the 15th and z to the 6th. Okay, and again, if it's all multiplied together, you can break it up and just do each piece one piece at a time, and then come back and just put it all together. So if we start with the square root of 27, if you start breaking this one down, 27 will be 9 times 3. And again, hopefully you go, well, square root of 9, that's a perfect number. So if I can take the square root of 9, that's just going to be 3. So that's going to leave me with 3 square root of 3. Okay. For the y's, again, the index of 2, we're going to divide 2 into 15. Go 7 times with 1 left over. And for the z's, when you divide 2 into 6, that'll go 3 times with no left over. Okay, so we've got 3, again, we'll put the radical part over here. We got 3 square root of 3. On the y's here, we've got 7 on the outside. Z's, we have 3 on the outside. And on the inside, we've got 1 y and no z's because it came out with a 0 remainder, so there's no y, or no z's in this case that go on the outside. Okay. And again, if you stack those up and just do everything for the y's underneath it, that way it kind of, and the same thing with the z's, every letter they give to you, it's the same thing. Whatever you get on the top here, that tells you how many you've broken out and put on the outside. Everything that's left over in your remainders, that's telling you how many of each one of those you need left over on the inside. Okay. And then the last objective in section 3. Actually, there was one more, but when we did objective 4, we also did objective 8, because objective 4, everything was square roots. Objective 8 switched up where we had third roots and fourth roots, so we just kind of put those two together because they kind of flow together there. But objective 7, this one is doing radicals with an index greater than 2. So now we're talking about third roots and fourth roots and fifth roots and that kind of thing. It's third root of 54. Okay, now, and with third roots, we don't do third roots as much, so this is one of those, if you start breaking it down, there may be some numbers that might pop up at you as you're going through these, but this is one of those numbers where you're probably, depending on how good your skills are, these are numbers you're probably going to have to take all these and break them down so that you get all prime numbers. Because with this index being 3, now instead of having groups of 2 for exit buddies, now you got to have 3 exit buddies. You got to have 3 of the same kind to break this thing out. So the index will always tell you how many you need to break out. That when we were doing square roots, everything was 2, so you had to have 2 of the same kind. You had to have 2 2s or 2 3s or 2 5s. If the index is 3, now you got to have 3 of the kind. You got to have 3 5s, 3 2s, or 3 3s. Once you do that, that's getting your exit buddy out and kind of going from there. Okay, so if we take the 54, start breaking it down. And I'm going to go over the stack method. Just kind of, it shouldn't be too long, but we'll go ahead and do it this way. It's even number, so divide it by 2. 2 will go into 54, that'll make 27. 27, you can divide it by 3. 3 will go into 27 9 times. And then 9 you can break it down as 3 times 3. So if we take the third root of 54 and rewrite it with our prime numbers here, that's the third root of 2 times 3 times 3 times 3. Well, if it's third root, there's our 3 exit buddies, so that 3 gets out. 2 only has itself, it doesn't have anybody to break it out, so it's going to stay as the third root of 2 on the inside. Okay, and again, these aren't really, it's not hard, but it's just, you know, if we're taking square roots and breaking them down, a lot of times we'll see the 16s and the 25s and the 36 that you kind of break out of it. We don't do third roots as much, so those numbers kind of tend to slip by, so that's one of those you're probably going to have to take these numbers and break them down, you know, a good bit till you can see what's happening over here. So let's, got one more number here, see if I can get this one in. We're going to do the fourth root of, let me back up just a second here. This is at the very bottom of the page. So for B on this one, we'll do the fourth root of 162. Okay, so take 162, start breaking it down. It's even. So you divide 2 into 162, that comes out to be 81. 81's odd, so now we're checking the odd numbers. We can divide it by 3. 3 going 81, 27, and you may go, well, 27 we did it here, yeah. So, gotta go 9, take that 9, divide it down, that's 3 times 3. So if you take the fourth root of 62 and rewrite it, it's 2 times 3 times 3 times 3 times 3. And because it's fourth root, we need 4 of a kind. Well, there's your 4 of a kind right there, so that 3 gets to go on the outside. The fourth root of 2, it was only the one here, so it will stay on the inside. And that winds up being the final answer.